So in this video, I'm going to go over how to simplify algebraic expressions that have negative exponents in them. So let's just go ahead and take a look at some examples and then see how we might simplify those. So let's say you're given something such as 3x and it has a negative exponent to the negative 2. And the question will, or the teacher will ask you to simplify that expression. Simplifying the expression can mean many things in algebra, and one of the things it means that if you do have a negative exponent, that you need to change it to a positive exponent. Well, how do we do that? So I'm going to show you first and then kind of explain what we're doing. This one right here, I would actually write a sort of a fraction bar here, and I'm going to leave the number 3 in the numerator, the top, and I'm going to move that x variable to the denominator, and I'm going to put that 2, but it's going to be a positive 2 now. So when you have a regular number like I did there, the 3x to the negative 2, the way we make that x to the negative 2, or the way we make the negative 2 positive, is to put it below the 3 in what you would call a denominator. So let's take a look at another one here. If I had something like 3x and then I had y to a negative 2, well, now the 3 I'm going to leave in the numerator, and then the x. Now the x I'm also going to leave in the numerator. Okay, so I'm going to have the 3 and then I'm going to have the x. Why am I leaving the x in the numerator? Because that negative 2 exponent does not affect the x. Now, we don't have an exponent written for x, but when there's not an exponent written there, what it really means is that it's a plus 1. So it's a positive, and I don't have to write the 1, but the point is that I'm not going to be moving that down to the denominator. But I will be moving the y, and I will take that, see, because it's a negative 2 for the exponent, I'm going to move it down to the denominator, and notice now I wrote it as a positive 2. So it's almost like magically when you have a variable with a negative exponent and it crosses that fraction bar there and dives down below it, the negative is erased. Okay, think of it right like that right now. And then let's have another one here. And now in this case, I'm going to give you one where I don't have the variable in the numerator. I'm given one as a fraction, and it's 7. And in the denominator, there's an x, and it has the negative exponent there, and negative 1. So I have the arrow drawn. So what I'm going to do, just like when I had the other ones where I would have a negative exponent, and I brought that variable and its exponent down below the denominator and made it positive, if you start out with a variable like this case, x, that's to a negative power, any number, you're going to move it up. Okay, so you're crossing that fraction bar again, and it's turning it to a positive. So if you start with a negative in the numerator like I did before, then you're going to bring it down as a positive exponent to the denominator. And if you have already, like this one I just did, where you have a negative exponent in the denominator, I'm going to pull that x up, and I'm going to have it 7, and I'm just going to write the x. Now I can write x to the 1, or I can just erase it. So see how that became a positive. So that's basically what we're doing. Pretty much think of when you have it in the numerator or denominator, if it's negative, you're going to move it to the other one. So what does a negative exponent really mean anyway? Well, the word is that it's called the multiplicative inverse. But most of the time, you're just going to think to yourself, flip it. Okay? You probably won't remember that name, and it really doesn't matter as long as you know what to do with it. And a lot of times just saying the word flip it, 2 words flip it, can give you a clue. So again, let's look at an example. Let's say I have just the number 5, not a variable, so you can have numbers to negative exponents. So 5 to the negative first power, all right? That is equal to 1 over 5, 5 to the first, or 1 over 5. What I've done is I've flipped the 5. Okay, I did 5 to the negative first power. The reason they call it a multiplicative inverse is because if you were to multiply the original, the number 5, and times its multiplicative inverse, which is the 1 over 5, you would get 5 times 1/5. 5 and 1/5 would come out to be 1. So multiplicative inverses of each other, the 5 and the 1/5, are multiplying to 1. But again, it really doesn't matter when you're working with these, you just want to know how to do them. So I just say flip it. Let's take another one. So if I could have, if it says 4 to the negative 2, and again, they're going to say simplify that. And when they say that, it means you don't want to end the answer in a negative exponent. That's just how they work. 4 to negative 2, I'm going to rewrite as 1 over 4 to the positive 2. Notice when I brought it down to the denominator, I'm making a positive 2. And then you probably want to go ahead and do 1 over 16 because that's what 4 squared is. Okay, so here's another one. I can just take a variable like n and I put it to the negative 2 power. Simplifying that, I'm going to write, now notice there's no number in front of n. I don't have a 3 or a 5. I don't have a coefficient. I just have the variable n. If there's no number in front of your variable that has the n has the negative exponent, so that the n and that exponent are going to have to move to the denominator. Well, what do you just don't leave the numerator blank? You put, if there's no number in front of the n already, just put a 1. So you're going to have a 1 there, and then when I put the n down in the denominator, and I put it to the positive 2 now because it was a negative before. And here's another one. You could get, again, be given 2, and then x to negative 3 is in the denominator already, so you just, again, flip it. Flipping the, now, okay, I'm not flipping the 2, because the 2 doesn't have a negative exponent. Like the first one I did on this page, the 5 was to the negative 1. That had a negative exponent. So a number sometimes has to move if it has a negative exponent, but the 2 in this one I'm going over right now, that it has a positive 1, and we don't write the 1, but that means it's going to stay right where it is because it has a positive exponent. But that x to negative 3 that's in the bottom, in the denominator, that's got to come up to cross that line up to the numerator, and I'm going to have 2x, and now it's a positive 3. So I want to take a look at a little bit more difficult problem that you would have to simplify, and of course it involves not just an negative exponent up there, but we're talking about division. Notice we have some x variable in the numerator, and we have an x variable in the denominator, and same thing with the y. So we're talking about, this is just your operations, this is going to be your quotient rule. Remember, when you're dealing with variables and you're either multiplying them or dividing them, this is the quotient rule because we're actually dividing. We've got some variables in the numerator divided by variables in the denominator. What do we do when we do that? That's when we end up subtracting the exponents. Okay, and I want to go over 2 different ways that I might approach this, and it depends on which you're most comfortable with. So one way to approach this is, I know I'm going to have to do subtraction of the exponents. All right, now some people will just do straight down, meaning I've got a negative 3 for the y, okay, and that would just end up subtracting negative 3 minus the 2. And I'm going to have, for the x variable, I have a 2 in the numerator, and I have a 5 in the denominator. I could do the exponent of 2, take away the 5. So I'll just do that as an example. So the number 5 is untouched. Again, it's to the first power. It doesn't move. And then I've got the x's. I've got the exponents, a 2 on top and a 5 on the bottom. So let's go 2 minus 5. And I'll simplify that in a second. And then for the y's, I've got a negative 3 in the top one, take away the 2 in the denominator one. So now go ahead and simplify that. You're going to have 5, and it's going to be x to the negative 3. And we're going to deal with that in a second. And then we're going to have y to the negative 5. So now I have negative exponents, and we're going to go back to the rules I was talking about. What do we do when we have negative exponents? And notice there's no more combining the x. There's just one x variable and one y variable, but they're to the negative powers. So this is what I'm going to flip them. I'm going to just put the 5, that's going to be in the numerator, and then the x and the y are both coming down to the denominator, and we're going to have x to the positive 3, y to the positive 5. So that's one way that you could do this. Okay, but now I want to show you a different way. But some people like to say, hey, which direction can I subtract so that I end up with a positive exponent? So we know that down here, this x is to the positive 5, and then up here is to the positive 2. You can subtract 5, take away 2. You can do it that order. Well, how can I do that? Well, what it means is I'm going to be thinking of starting here in the denominator, that x, and when I get the answer of the 5 exponent, take away this 2 up there, that answer, or x to the 3, that's what's going to go in my denominator now, x to the positive 3, which is what I ended up with last time anyway, but sometimes this saves a step. And again, so I'm going to do 5 again for the y, but right here I know that if I take the y to the plus 2 and subtract the negative 3, and again, because I'm starting with this one denominator, that means that's where the exponent answer is going to go. So I have the 2, I'll put this over here, I had a y and I have a 2, and I'm taking away, we're always subtracting as a division, and I'm taking away this negative 3 exponent up there. All right, so that 2 take away negative 3 is going to be a positive 5. And this is what I ended up last time anyway, but it kind of saves a step. So you can look for which direction is going to give you a positive value. So again, like, let's say that this wasn't y to the negative. This was I guess, let's say this is something like, I had that of y to the fifth, okay? And so just because for this one, when the x's, this doing here, where I took the 1 in the bottom, that 5, subtracted the 2, and then left my answer down here, because that's the direction I subtracted. I don't have to do the same thing for this y. They're separate. So now I go, oh, wait, up here, there's a y to the positive 5, so why don't I do 5 minus 2? Instead of this thing, I'm going to go y to the 5 minus 2. And notice I put it up here because I'm starting that subtraction from the numerator. So I got y, in this case, I get a y to the 3. So then it just ends up there. And then, so it doesn't matter which direction you do. So sometimes you might want to do one versus the other. And I just want to point out, sometimes you have a situation like this where I've got 3x cubed, it's in parentheses, and that's raised to a power, but the power is a negative 2. So there's a couple ways I could do this here. This is the power rule, right? It's because I'm raising something in parentheses to a power. And what do we do there? We're going to multiply those powers. But for the 3, looking at the 3 in front there, the coefficient, there's a 1 because it's not written. So I'm going to have the 1 of that exponent there for that 3 multiplied times the negative 2 that's outside. So it would be 3 and then a negative to the negative 2. Then I'll take the x that's cubed, and I'm going to multiply that 3 times the negative 2, and I'll get x to the negative 6. Now that can simplify to, I'm going to put the 3 to the 2 on the bottom, but as 3 to the positive 2. The x to the negative 6 is going to come down as an x to the positive 6. Well, now I have nothing left in the numerator. Well, when that happens, if there's nothing left, just put a 1. Okay, and then I made the 3 squared to 9. Now, that's one thing I could have done, but I also could have done it a little bit different way. Instead of multiplying like I did the power rule, put everything in, I took the whole parentheses up there, the 3x cubed, which is to the negative 2, and I put that, right away I put that parentheses, 3x cubed, down in the denominator, and in parentheses still, and all I did was bring, instead of a negative 2 power outside of it, I just brought that parentheses down, and see how that's a negative 2 power up there, but I'll just bring it into the denominator, and now I'll just make it a positive 2. And then, again, there's nothing left on top, so I'll just put a 1. So I'm going to end up the same way, and then I'm going to simplify it from there and get the square that parentheses. But the point is I can move the whole parentheses down like I just did, which was to negative 2, and just make it positive 2. Okay, so now I want to go through an example of one where I'm actually having two fractions here. I'm multiplying with a lot of variables. So in this case, the question is, you could simplify this whole one right here, and then simplify this one, and then deal with them. So you could do that, but I would prefer in this situation. So in other words, I could take this x of negative 2 and subtract the negative 2 here minus the 3 there. But I would rather multiply straight across, because we are multiplying these two big fractions here. So what I'm saying was I'd like to go the 7 times the 15. So that's going to be a 105 on top. And notice I have an x to the negative, this is an x to the negative 2 right here, and I have an x to the 4. So this is the product rule. I'm just multiplying x to the negative 2 times x to the 4. What do? We add the exponents. So I'm going to have that negative 2, and then this 4 here plus a 4, it's going to be a positive 2. So I write the x to the positive 2. And I'm not going to have to move it down because it's a positive now. And then we're dealing with the y's here. Well, this is y, when it's not written anything, it's of course y to the 1. And this is a y to the negative 1. So you're adding the 1 and the negative 1. You get y to the 0. Anything to 0 is 1, so I don't have to write anything on the top there. Now I'm going to have a denominator. Down there I've got a 5, and no number over here, no coefficient over there, so I'll put a 5. And I've got an x here, cubed, and I've got x to negative 1. So again, I'm going to multiply these x's, right, straight across. X cubed times x to negative 1. I'm going to add the 3 and the negative 1 here with the product rule. That's going to come out to be positive 2. And then here we go. This is a negative 5 exponent in the denominator, so I got to bring it up, flip it, bring it up to the numerator, and that negative sign goes away. So you have a y to the 5th up there. then just including this 21, it ends up 21y to the 5th.